So we're looking at section 2.2, which is on linear equations. And if you recall last class, the types of graphs we formed were lines, every single one that we drew, right? We drew lines that had a positive slope, a negative slope. We didn't talk about lines that have a slope of 0, but we will today. And, you know, there's another kind of line also that has a slope that's called undefined. It's just not calculable. So we'll get into that a little bit more today. But the first thing that we want to do is to be able to solve a linear equation, which is an equation that has linear expressions in it. And so these expressions would involve variables that are raised only to the first power. Okay, so like x to the first, y to the first. Okay. And so there are 3 types of linear equations. And this actually works for other types of equations as well. So there's a few types of equations that we could have. And the first one is called a conditional equation. And so if you remember like a conditional statement, if today is Wednesday, then tomorrow is Thursday, right? That you have a hypothesis, you have a conclusion. And the first part is kind of like your what you know now. And the second part is then what you will know from that original statement. Same thing with equations. What we know now is what we're given, the given equation. What we want to know is the answer. What is x equal to? Okay, now so a conditional equation has a solution. There we go, that's pretty nice. It has a solution. An identity also has a solution, but it has an infinite number of solutions. And lastly, inconsistent is kind of what it sounds. It's an equation that has no solution at all. Okay, now I'm going to go over an example of each of these, and we'll see what your outcome looks like. Okay, so the first one, a conditional equation could look like this. 2x minus 4 is equal to negative 5x plus 10. So if I'm solving this equation, I'm kind of assuming some things here. I mean, I don't want to assume all of your prior knowledge, but I'm kind of assuming that you can solve like a one-step linear equation, okay, or maybe a two-stepper. And those would look kind of like this. 2x plus 5 equals 10. Is that okay? Okay, so I do know that my goal is to isolate x, and the same goal occurs in any of these equations. Okay, so my goal is to isolate x, but in this equation, the x's there's 2 of them, and they're on opposite sides. So if that happens, we need to move them together. Okay, so I would first start by moving one of the x terms. It doesn't matter which one. And you move them using the inverse operation. So if it's a positive number, you know, that's like a plus, you're going to subtract. If it's a negative number or a minus, you're going to add. And so I would add 5x to both sides. Okay, and that way this will result in a 0. And then also at the same time, you can do 2 moves in one step if you would like. So at the same time, I'm going to move this minus 4 to the other side. So I'm going to add 4. Okay, add 4. And now I get this new equation. 2x plus 5x, which is 7x, good, is equal to, okay, those cancel out, 10 plus 4, 14. And here is a one-step equation, right? So we went from multi-step to one-step, and now what do we do with the 7? Divide, that's right. Divide by 7, and x is just 2. Okay, so here is our answer. X is 2. Now we can also check our answers in an equation. And all we would do is take that 2 and plug it back in the original expressions. And so I'm going to plug 2 here and here. And we can just do a quick mental check if we are able. So that's 2 times 2 minus 4. Okay, so 4 minus 4, or 0. Negative 5 times 2, negative 10, plus 10, which is 0. And 0 equals 0. Those sides are equal to one another. This value creates a true statement, right? So altogether, what I can read, I mean, I'm just going to say x equals 2, but I could say if 2x minus 4 equals negative 5x plus 10, then x equals 2, right? Okay. So that's our first type, a conditional equation that has a solution. And for linear equations, they have exactly one solution. Just one. An identity. I'm going to give you, here's a little game. Okay, I'll call it a game. It's a math game, though. So if you need a calculator, you can have one out. Are you ready? Take the number of the month of your birthday. Okay, so I'm September, so I'm going to take a 9. Okay, so have that handy. Multiply that number by 5. Then add 6. Okay, multiply that result by 4. And then add 9. Okay, multiply that result by 5. Add the number of the day of your birthday. And so I would add 16. Okay, but you add whatever you think. And lastly, subtract 165. Okay, what did you get? Did you get my birthday, 9/16? No. Okay, what did you get?
My birthday.
Your birthday, and you got your birthday? Okay, everybody got their own birthday. Is that crazy? Okay, so a little bit of magic, but that's a little bit of algebra. And we can go through the reasoning for this really quickly. I think you probably want to know, right? Okay, so let's go through. Okay, so let's let x be the number of the month, and y be the day of your birthday. And so we're going to work with x for a while. So take the number of the month. So we're going to take x and multiply the number by 5. Yes?
Are we doing the identity?
This is going to fall under identity. Yes. Okay. So 5x. Add 6 plus 6. Multiply this result by 4. So you have to multiply the entire result. Parentheses are needed. 4. Add 9 plus 9. Multiply by 5. Again, the entire result multiplied by 5. So put another set of parentheses or brackets. Add the number of the day. So to this, you're going to add y and subtract 165 minus 165. Okay, that doesn't look like an identity right away, but let's go ahead and try to simplify. And so we start inside the parentheses, right? So that's 5 bracket distribute. Okay, 4 times 5, x, and then 4 times 6. So we have 20x plus 4 times 6, 24 plus 9 plus y minus 165. Okay, continue simplifying inside the brackets because we have like terms, right? We have the 24 and the 9. So we add those together. So we get 33, and so that's 5 times 20x plus 33 plus y minus 165. Distribute again. Okay. And that gives us 100x plus 5 times 33. Let's see. I mean, isn't that 165? Okay. 165 plus y minus 165. And now we see that those two values cancel one another out, right? So I just cross them out. And altogether, we say 100x plus y. So I'm saying this is an identity because it worked for any x and any y, right? Any x and any y. But why does it work? So if I take 100, so times 9, for September, so I get 900, and then plus 16, and altogether I get 916. Good? Okay, so kind of nice, but this is just an idea of what an identity could do, but it would work for any x that you plug in. This one just happens to have a y also, okay? A typical identity that we will see.
So with any x, there'll always be a solution for an identity?
So yeah, identities produce solutions. They produce an infinite number of solutions, okay? Yeah, so definitely have solutions, just any real number that you could think of would be a solution. So we would typically just say all real numbers for the answer.
All whole numbers.
Yeah, all real. Even in our case for any identity, not the birthday one, but it could include decimals and fractions too. Yeah. Okay, so one could look like this. Negative 5 times x minus 2 plus 3 is equal to 13 minus 5x. Okay, so right away it doesn't look like an identity, but let's simplify. So what we're going to do is distribute. Okay, so typically if you see parentheses, a binomial with two terms and a number on the outside, go ahead and use the distributive property that I multiply those together and I get negative 5x. Negative 5 times negative 2 is positive 10. Bring down the plus 3 and bring down the other terms, right? But look at the 10 plus 3. 10 plus 3 is 13, and look at this, there is a 13. You see that those two sides are equivalent to one another, and that's what our goal is. If you find those sides equal exactly, they look exactly alike, you can stop, and you can say, that's an identity, and therefore, there's all real numbers for the solutions. But I'll go one step further so you can see how these two really match. So negative 5x plus 13, and then I'll rearrange this using the commutative property, negative 5x plus 13, and then I know there's all real numbers for the solutions. In XYZ homework, you may put infinity just as your answer for an infinite number of solutions. Okay? Well, one other, inconsistent. If you have an equation that looks like this, negative 3x plus 1 is equal to x minus 4x plus 5. We try to simplify. We try to solve for x. That's our goal for any of these. And I combine like terms on the right. Okay, so the left-hand side currently stays the same. The right-hand side, x minus 4x, is negative 3x, isn't it? Bring down the plus 5. And then typically what I would do in any equation is try to get the x's together, right, if they're on opposite sides. So I'm going to move one of these negative 3x's to the other side. And to do that, because it's negative, I would add, right? That's the same thing like a negative number in subtraction. So I'd add 3x to both sides. And all together, okay, those cancel. We are left with 1 equals 5. An untrue statement, right? It's a contradiction. If you reach a contradiction when you are solving an equation, there's no solution to that equation. So we say that is definitely not equal to one another. No solution. Okay, any questions so far?
Is there no solution option in X, Y, Z?
Let's see. You may end up typing DNE for does not exist. Okay? But if that doesn't work, let me know.
Okay.
Okay, well, we have some other kinds of equations. These don't look like linear equations initially, but they do have linear terms in them. Do you see how x is raised to just the first power? It's just an x. It's not an x squared, right? X cubed. So our goal is to rewrite, I guess, huh? Reconfigure, yeah. That we're trying to manipulate this in such a way that it changes the outcome. You know, it doesn't change the answer, but it changes how the equation looks. And so I think that's our first goal. Now, these are called rational equations because they're made up of ratios, right? A ratio, a fraction, and they involve x's in the denominator. I mean, because if it were just any old fraction, like 2x over 3 is equal to 1/2, that is the same thing as 2/3 x equals 1/2. You see, and I can just divide by 2/3 on each side to get rid of this 2/3. Or more simply and faster is to multiply by 3/2. That's what you would end up doing. So this is a nicer version because there's no x's in the denominator. These are not so. So we got to do something different. Now, there are a couple of different ones that I see. This first one is actually called a proportion. And do you know if you see a proportion, it would look at the form A over B equals C over D. Okay, if you see that, A over B equals C over D, the fastest way to get rid of those fractions is to cross multiply. Okay, so what you end up getting is A times D and B times C. So A times D equals B times C, and how I got that was just to multiply on the diagonal. Good? So that's what we'll do for the first one. Now, there is a negative in front of this first fraction. You need to put it with either the numerator or denominator. It has to go with one of them. because this is a negative, it creates a negative number potentially. I would suggest, make a recommendation that it goes with the easier of the two expressions. And so I'm going to put it next to the 2. If I decided to put it next to the 4x minus 3, it has to change both signs in that denominator. And that may be, you may forget, to do that. So I'm just going to move that negative right up there. And now I know exactly what I'm going to multiply. So negative 2 times parentheses 2x plus 1 is equal to 7 times 4x minus 3. And that is now, it now looks like a linear equation, doesn't it? And we know how to solve that. And so first we'll distribute. So negative 2 times 2x, negative 4x, negative 2 times 1, negative 2 is equal to 7 times 4x, 28x, and then minus 21. Good. At this point, we have to move the x's together, the constants together, right? So you have to do some manipulation, but you can do them both in one step if you would like. So what I typically start with is to move an x term. And I consciously choose the smaller one to move. So I'm going to choose to move the negative 4x. Okay, so that way I always have my steps. Like I'm never going to, veer from these because I know this works. So it's going to be plus 4x plus 4x. But if I moved that, I now need to move this negative 21. And so we're going to add 21, add 21. Okay. Now, if you moved too many things, like if you moved things to the wrong side, that's not incorrect. It's just probably not getting you where you need to be. So you still are doing correct mathematical algebraic things. Just it may not help you progress. So altogether, if we see kind of what happened here, okay, that disappears, this disappears, and we add. And so we're left with negative 2 plus 21, so 19, is equal to 28x plus 4x, or 32x. How nice is that? And lastly, divide. And here is our answer. X equals, it's not a nice one, 19 over 32. If it is a fraction, I would recommend leaving it as a fraction. Because if I use my calculator right now and divide 19 by 32, I get a kind of long decimal. You either need to type all of those digits to be an exact number, or just leave it as a fraction, right? How nice, it's better to just leave it as a fraction. Reduce a fraction if you need it, but, fractions aren't the enemy. It sometimes may seem like that, though. Okay. Now, you can still check your answer. May not be as easy, but it's definitely possible. So let me show you my calculator really quickly, and let's make sure that we are able to all check our answers.
So when you plug it in, they should equal each other?
That's right. That's correct. Okay, so mine may look a little bit different than yours, but this is still the same concept that you could do. So I'm taking my first fraction, negative 2 divided by, and you may have to enter parentheses around the denominator. So be sure to include them. 4 times whatever your outcome was, because it was 4x, but we found x to be 19 over 32? Okay. 19 32nds minus 3. Close. Okay, so now that will give us what the value of the left-hand side of the equation is, 3.2, if x is truly 19 32nds. But we also need to make sure it matches the right-hand side. So 7 over 2 times x 19/32 plus 1. Okay, 3.2. Our answer is correct. Okay, well, let's try another one. Sometimes instead, this is not a proportion. We could do a couple of different things. There's different methods for solving these. So you could, in fact, make a proportion if you had wanted to. That's an idea. I typically don't do that for these types of problems. I'm just going to try to eliminate the fractions altogether at first. Okay, so it's not like you're having to do an extra step. Hopefully this is a little bit faster. So how to eliminate the fractions? Okay. Multiply both sides of the equation. Take a look at those denominators really quickly. We have 3x, we have 2x, and we have a 3. We want the least common multiple of those denominators, sometimes called the least common denominator, like LCD. So what numbers would each of those denominators go into? But I want just the smallest one possible. A 6, good. What about an x, right? So altogether, I think we want a 6x. Now, if you get stuck, if you say, I have no idea which numbers, you can multiply all 3 of these together. That's not the least common denominator, though. And it will work, but it's just going to probably make it look more complicated. So try to think about the smallest common multiple, okay? And I would say 6x, yes. Oh, sorry. Okay, so 6x. And you're multiplying both sides by 6x, so maybe I'll make it very clear. This is what we're doing. 6x, 6x. See that? And distribute on the left-hand side. So hey, my next step is optional, but I'm going to do it just because I think it'll make it even more clear. So it's 5 over 3x times 6x minus 4 over 2x times 6x equals 8 over 3 times 6x. Do you see now I can work with the numbers that are beside one another, so that may help it a little bit, make it easier to simplify. Okay, so the x's cancel in this first group. 3 goes into 6 2 times. So we're left with just 5 times 2. Okay, so that becomes 10 minus. In this next group, the x's cancel. 2 goes into 6 3 times. 4 times 3 is 12. Is everybody fine with that? Simplifying?
You said x's cancel?
Sure. So treat this 6x is like, I think you said last time, can you put it over 1? Do that. 6x is like 6x over 1. And so those would both be in, one's in the numerator, one's in the denominator. I'll write it out, hopefully a little bit more clear. So 5 over 3x times 6x over 1. That you could instead put all of this as one fraction. 5 times 6x over 3x times 1. And now you see x divided by x is 1. That's how they would cancel. Does that make sense?
I guess I was like thinking like there's 3 x's and there's 6 x's.
Oh, good question. So I think you're...
In my head, I was like, oh,
yeah.
2 x's left over.
That's right. So 3x is x plus x plus x, but it's not x times x, which is maybe what you're thinking. That would be x cubed instead. So yeah, just x and x. If it's multiplication between them, you can just cancel these because this is division, if that makes sense. Okay? So,
I'm sorry, now I'm just left dividing the numbers.
That is correct. So now you're just working with the 5 times 6 over 3. And you can divide 3 into either of them. I mean, it doesn't matter, but 3 doesn't go into 5 evenly. So I'm going to try to reduce by dividing it into 6. Okay. Now, over on the right-hand side, what am I left with? So 3 goes into 6 2 times. 8 times 2, 16. But don't forget, the x's, there was no other x, was there? So we are going to have, 8 times 2x, but total 16x. Okay, now this looks a lot better. So it took a second. It was not as easy, but we found an equivalent equation. And 10 minus 12, those are like terms. So that's negative 2 is equal to 16x. And then lastly, divide by 16. And we get x equals negative 2 sixteenths, but that can be reduced to negative 1/8. Okay, now again, check your answer. It's very important. But one thing that I'm also concerned about in rational equations is that there are often, anytime you change forms in an equation, like what we did, it was rational to begin with, then it was linear. Anytime that happens, you could introduce extraneous solutions. I know that sounds strange, but extra solutions, right? Extraneous. So solutions that work for the new equation, but don't work for the original equation. So definitely verify your answer. I really want to kind of move on to my graphing. So what I'll do is post an example later in Blackboard of another one that has an extraneous solution. Is that fine? Okay, so I want to get to some graphing lines. Okay, so our goal, another goal in this lesson, is to be able to write linear equations. Now, we talked about last time how if we have 2 points, any 2 points in the coordinate plane, we can graph a line, right? Through any 2 points, there is exactly one line. Well, we can write an equation of a line as well using just 2 points, so that's nice. What we need for an equation of a line is typically the slope of the line or how slanted the line is. And so the slope formula, we typically denote slope with an M, so M for slope. The formula, what it calculates is a ratio. It's how y is changing, so change in y, over how x is changing, change in x. And it's just used those little delta symbols, delta y over delta x. And then here's what you're actually calculating, y2 minus y1 over x2 minus x1. Is that pretty familiar, your slope formula?
It's been a while.
It's been a while, but yeah, have it handy, have it written down. Okay, well, after that, we have many different forms of an equation of a line, depending on, what information you're given initially. So one that we saw last class, when we were trying to graph some lines, they looked kind of like this, 2/3 x minus 4. This is slope-intercept form, right? Y equals mx plus b. So the slope of this line is 2/3. That doesn't look like an arrow. 2/3. The y-intercept is -4. Okay. So slope-intercept form, for me, that's a good form to have. I just really love this form because you have everything you need to be able to plot the equation of a line. So why don't we, I have some, sorry about this, I do have some graph paper if you don't have any remaining, from last class, if you want to pick up a piece at the back of the room. Okay. Otherwise, you can just do a quick sketch on your paper. But why don't we just try to graph this equation really quickly? Okay, y equals 2/3 x minus 4. Now, to do that, if the equation is in slope-intercept form, the first thing I would plot is a point. And a point that we know clearly is the y-intercept. So go down on the y-axis to -4 and put a point. Okay, from that point, we're going to count what the slope is. And the slope is 2/3. Okay, so if m is 2/3, that tells us how y is changing as x changes. So as I typically count up first, okay, up or down. As I go up 2, I should go over 3, right? That's going to tell me how slanted my line is. If you want to think about it differently, this may confuse you though, but if you want to think about it differently, you could say, as x changes by 1, y changes by 2/3. That's another idea. But when I'm drawing this on the graph, trying to graph 2/3 is not easy, right? That's 2/3 of a space. So I'm going to do it this way instead.
Is that like rise over run?
That's it. Rise over run. Good. Rise to, run 3. That's right. Good. So up 2, 1, 2, over 3. 1, 2, 3. Put a point. You could continue if you need to, but through 2 points there's one line, so this is it. Connect them, and this is our graph. Okay, let's take a look at a negative slope, what it looks like. And let's all together, I kind of want to go over just what different slopes look like if we have time. So draw a number line next to your slope formula, and in the middle put a 0. So if your slopes are closer to 0, your line is more flat line. Okay, so if your slopes are closer to 0, your line is flatter. The farther you get away from 0, the steeper your line becomes.
If your slope is close to 0, it's more flat.
That's right. Which means if your slope is 0, the line is completely flat. It's a horizontal line. Okay, well, let's try another one. Negative 4x plus 2. Negative 4x plus 2. So our m is -4. Our b is 2. Okay, so the first thing we plot when graphing a line is a point. Okay, I need a point to start with. Even if I know the slope, I can't just start anywhere. And this point I know is at 0,2.
You're welcome.
So no matter what, when you're starting to draw a line, period, you need to start with 1 point and then go from there. The slope is not going to help me until I've started to draw a point, right? Because I'm going to count from where I know a point that's on the line, I'm going to count the slope. If I start at any random point and count the slope, I end up with just a parallel line to the original line, which is not what I'm trying to graph. I'm trying to graph this line specifically. So anytime, period, if you're given a line that looks like this, graph this number first.
Okay, what does B stand for again?
It's the y-intercept.
Okay.
I'm so sorry if I didn't say that, but the y-intercept is what it stands for. Okay, so now the y-intercept is 2. We plot a point at 0,2. Okay, the slope is -4. Now, I may get a fraction if it's not 1. So I'm going to put it over 1. And again, this is change in y over change in x. So what direction should I count from the y-intercept? So I could go to the left. If I did decide to go to the left, I'd move that negative down to the 1 because that tells me the horizontal direction that I'm going to count. But because I'm going to typically start with counting the y's, I just do that same thing over and over again. I'm going to count a negative vertical direction. So that would be down, right? Down 4 as I count right 1. Good. So as x changes in a positive direction. So from here we count 1, 2, 3, 4. 4 down, right 1, and there it is. And see how steep that line is, right? Because negative 4 is farther away from 0 than our last slope that we had. Well, there's other forms of lines. It doesn't have to necessarily be in slope-intercept form like this one. So point-slope form is just a modified version of the slope formula. So you can kind of see how the x2 minus x1 relates to the x minus x1, and the y2 minus y1 relates to the y minus y1. So this is pretty much the same, just transformed version. But it's a helpful form, and we'll use it in just a minute, okay? Another form we saw the other day, remember when we found the x and y intercepts, if we were given an equation of a line? One time the line was given in standard form. It looked like this. 2x plus 3y equals 12. You see that? And you could easily find the x-intercept and the y-intercept by just covering up one of those terms. Okay, so the standard form is a helpful form to have as well.
So the first two graphs we plotted were the y-axis and x plus.
That's right. They were both in slope-intercept form. That's correct.
What about plots different?
We may. I kind of want to write some equations of lines, but why don't we do one in point-slope form really quickly? Okay. So what about y minus 2 equals negative 1/3 x plus 3. Okay, well, right away, I notice this looks most like point-slope form. So I'm going to write point-slope form but below it, and we can match up all of these things. Y minus y1 equals m, parentheses x minus x1. There is an issue, though, because we have a plus in the given equation, but we have a minus in this form. So I'm going to change a plus, because I know addition is the same thing as minus a negative, right? Okay, so I'm going to rewrite this as y minus 2 equals negative 1/3 x minus negative 3. Now I know exactly what x1 is, y1 is, and m is. Okay, so y1 is 2. M is negative 1/3. X1 is negative 3. And we're going to say this line has a slope of negative 1/3 and passes through the point x1, negative 3, y1, 2. Does that make sense? Kind of so far? So, do I know the y-intercept? No, this is not the y-intercept. Do I have to know the y-intercept? Luckily, no. I just need a point to start with. So let's graph that point first. Okay, so our point is at negative 3, 2. That's in quad 2, negative 3, comma 2. And from there, we're going to count this slope, negative 1/3. What direction should I start?
Down
Uh-huh.
1/3.
That's right. Down 1, right 3. And then here it is a point, which happens to be the y-intercept. I now know what the y-intercept is. And if instead, if you say, gosh, I don't know where to put the negative, it doesn't matter if you instead put it in the denominator. Okay, as long as the number is negative, it needs one negative. So you could instead count up 1, left 3, and you end up still at another point that's on the same line, whichever one you want to do. But so I just kind of take, do I have enough space to count, down and over, or do I need to count up and left? And if that's the case, I use this fraction instead. Okay, and connect them, and here is our line. Okay. Well, the other two forms at the bottom, a horizontal line is always of the form y equals a constant, like y equals 5, okay? Y equals 5. That all of the y values are exactly the same. A vertical line is of the form x equals a constant, like x equals 2. All the x values are exactly the same. But let me talk about their slopes really quickly. We talked about the slope of a horizontal line because that would be the flattest line possible. It has a slope of 0. A vertical line is a little bit more complicated. So let me give you a quick example, okay, of trying to find a slope of a vertical line. Let's see. Okay, let's say the points of a line are 5, 2. A couple of points of a line are 5, 2, and 5, 0. Okay, and I didn't know what kind of line this was. I can always graph really quickly just to decide what kind of line it is. But say I started trying to find the slope of this line. Let's try it and see what happens. To find the slope, if you're given two ordered pairs, you can label them, oops, don't do that, x1, y1. Oh, don't do that. x1, y1, and x2, y2. You can label them like this and just fill in the slope formula. Okay, so our formula is y2 minus y1 over x2 minus x1. Okay, y2 in my example is 0, so 0 minus y1, which is 2, and x's are 5 and 5. 5 minus 5. Okay, so that's negative 2 over 0. Can we mathematically divide by 0? I try it right now. Negative 2 divided by 0. Error message, right? Dividing by 0. It's undefined mathematically. So that's when we're going to say the slope of a vertical line, because that's what this is. The slope of a vertical line is undefined, okay, because we'd have division by 0. And that's all you're going to write. Okay, the equation for this vertical line, how nice is this? If you notice that the x's match, here's your equation, x equals 5. Good? Pretty nice. If the y's matched, you have an equation, y equals whatever number. So try to notice that initially if you're given 2 points. And I know x equals 5, that's a vertical line. Okay? Okay, so the last things that we're going to do is just try to write equations if we're given some information about a line. Okay, so the first one, we're going to write an equation of a horizontal line that passes through the point 2, 4. Okay, horizontal line passing through the point 2, 4. This is one of our special lines. And so you can go back to recognizing what the form is. So from the last slide, what do these look like? Horizontal line.
Has a slope of 0?
It does have a slope of 0, yes. So truly, you could use slope-intercept form if you really wanted to, or point-slope form if you wanted to. You could use one of those forms because a slope of 0 leaves us with an equation that looks like that. Y equals some number. How nice is that? So you can definitely use slope-intercept form, but it's not necessary. Just remember, y equals some number. What's the y coordinate of this point? 4, right? Yeah, so just look at the y value. The y coordinate is 4. Here is our equation. Y equals 4. Is that not nice? So you know what kind of line it is. You know what those lines, the equations of the lines look like. Y equals some constant. And that constant is a specific number. It's a y value. Okay. Number 2, a line with a slope of 1/2 passing through the point -4, 1. Okay. For this one, I'm going to use point-slope form to write the equation initially. So point-slope form, again, is y minus y1 equals m times x minus x1. Okay. And I get y minus the y coordinate, so y minus 1, equals m, the slope, which was given as 1/2, times x minus the x coordinate, -4. Here, if they said, what's an equation of the line? Here it is. Here's an equation of the line. Is this the most simplified version of an equation of a line? No. I would say try to get it in slope-intercept form, and they'll probably have you write your answers in slope-intercept form. So we just have to do a little bit of simplifying. So bring down y minus 1, bring down the 1/2, but change this to a plus. So x plus 4. Distribute the 1/2, and we get y minus 1 equals 1/2 x, 1/2 times 4, so plus 2. And then one other thing, because we need y equals, right? Y is by itself. So we're going to add 1, right? Plus 1, plus 1. Y equals 1/2 x plus 3. Okay, that is the answer for that equation. And you may wonder, why didn't I use slope-intercept form, y equals mx plus b? And what I noticed from my given information, this point is not the y-intercept, right? I would know it's a y-intercept if x were 0. So take a look. If you're given the y-intercept, that would have been even easier. I would just go straight to y equals mx plus b form. If not, no problem. Do a little work, and then you get the answer.
So why, can you say again why we chose point slope form?
Because the point we're given is not the y-intercept. Does that make sense? Because the y-intercept would have a 0 for the x-coordinate.
Okay, good.
So you're saying it can't be a negative?
So the slope, the y-intercept could be a negative number, but the x-coordinate would always be a 0 for whatever y-intercept it was. So negative, positive, that doesn't matter, but the form of this point shows me this is not the y-intercept. I'll write that down. A y-intercept is always of the form 0, some number. 0, some number. Okay, and that's just a constant, but that's not what this point looks like, so we know it's not the y-intercept.
Okay. So then we make it into that.
That's right. Then you're converting. You start with point slope form, a form you know will work, and then you convert. That's it. Okay, well, let's see if we can try this next one, the line with the given graph. Okay, notice you may be given a graph, and this y-intercept is a fraction, right? If that's the case, I'm not exactly sure that's a very nice number, like a nice fraction, like negative 4.5. I'm not sure. And I could try it, but I want to be very, 100% sure that my equation is true. It matches this given graph. So instead, I'm going to pick some points that are really clear, that have integer coordinates. Choose integer coordinates, right? Numbers like 1, 2, 3, 4, 5, where they're opposites, or 0, you know? Okay. Okay, see ya. Have a great day. Okay, so I'm going to mark this point right there and this point right here. You see how those look like they have integer coordinates? 1, -3. And 3, 0. Okay, now from here you decide, count the slope if you count the rise over the run from the graph. The other option is to use the slope formula, y2 minus y1 over x2 minus x1. Okay, so why don't we just try to count on the graph. We're going to count up and over to get from one point to the next. So up 3 spaces and over 2. Now, my slope is 3/2 then, right? 3 over 2. It's definitely a positive slope because see how the line is slanted upwards from left to right, that it's increasing from left to right. Make sure that your sign, S-I-G-N, of your slope matches the way the graph is slanted. Okay, so don't get the sign of your slope wrong.
Okay, so explain that to me again, how you got the slope.
The slope. So what you're going to do, pick 2 points that are very clearly on the line that have integer coordinates. So I picked ones that pass through, when the grid lines intersect, try to pass through the corners of the grid lines. So once I did that, you can draw a right triangle. Just draw it, go up and over, or down and up, down and over. So I'm going to count this number of spaces, which is the rise, and that's 1, 2, 3 spaces.
And you got that from the 0, the 3, 0?
The 3, 0. I didn't get that. I did get how to get from this point to this point by going, counting on these vertical or horizontal lines. So I knew I needed to go up until I reach the y equals 0, yes. Okay, but I didn't really use that, this 3 yet. You see, so I went up until it reached the y equals 0, and then I went over till it reached the next point. Okay, so up and over. And I went up 3 spaces and over 2 spaces. So if you think about this right triangle, think about the sides of that right triangle, if that helps. You can maybe draw it. This is what we kind of did. We went from here to here, up 3 spaces, over 2 spaces, and ended up at another point on the line. Okay? Now, if that is hard to see, because it could definitely be hard to tell from a graph that's given, use the slope formula. y2 minus y1 over x2 minus x1, and plug in these ordered pairs that we have written.
How do you know to use the equation? Like, how do you know how to pick which equation?
Good question. Okay, first of all, decide, is your line a special line? Is it horizontal or vertical? No, it's not one of those. So it has a slope that's like other than 0 and is defined. So that's good news. If it's one of those, I would use either slope-intercept form or point-slope form. You can really use either for any line, but one's better for some, right? Just depending on the given information. Did I write down what the y-intercept of this line was? No, because I was unsure of it.
Can't use
We're not going to use slope-intercept form, right? We're going to use point-slope form instead, if that makes sense. Okay, but we're not there yet. All we're doing right now is finding the slope, if that makes sense. Okay. So yeah, if you know it's not one of those special lines, first thing, find the slope. Okay. So that's 0 minus negative 0 minus negative 3, whoops, over 3 minus 1. Okay, so 0 minus negative 3 over 3 minus 1. And that's 3. 0 minus negative 3 is 3 over 3 minus 1, which is 2, 3 halves. That's the slope.
And now we use
That's right. Good. Yeah. And so now I'm going to just move over to the side, pick one of the points that were given, doesn't matter which one, either one's fine, and we'll use point-slope form. But look, the x-intercept is kind of nice because it has a 0 as the y-coordinate. So what if I choose that point? The other point would have worked the same way, though. So we'll select this ordered pair and this slope. And we're going to plug those numbers in these spots right there.
But you could pick any of them.
That's correct. Any point on the line will work. Okay? Okay, so y minus, this y value is just 0. So y minus 0 equals 3 halves, parentheses, x minus 3. And now that's y equals, distribute. So 3 halves x minus 3 halves times 3. You multiply the 3's together, so it's 9 halves. Okay, 9 halves. But that is negative 4.5. And that's kind of what I thought this point was, but I didn't want to assume for decimals, fractions, that's kind of where you're guessing a little bit. So it ended up being negative 4.5 for the y-intercept. That's good. And here's my, well, we have one, this is kind of a long lesson. I'm very sorry. It's pretty much like 2 sections in one, right? But I still put it on one day. So if you will bear with me, I'm going to talk about parallel and perpendicular lines really quickly.
On test, are you going to be given the equations, or are we going to memorize?
You luckily do not have to memorize them.
Cool.
You can write your own formula sheet. Okay, so just write them on a one-page piece of paper.
Does it have to be handwritten?
Handwritten, yes. Now, for your typical test, I mean, I'm not really going to notice anything. I'm not going to look at your formula sheet. But for the midterm and final exam, you know, make sure it's that one-page handwritten formula sheet. Okay. Okay, so lastly, writing equations of parallel and perpendicular lines. So here's a good thing. It's no harder than writing equations of other lines, okay? But the difference is you have to know that parallel lines are slanted the same way, and so their slopes are equal. Right? So parallel lines have equal slopes. Perpendicular lines are not slanted the same way, right? They intersect at right angles, but their slopes do relate to one another. So perpendicular lines have slopes, so they look like this, where they intersect at a right angle, have slopes that are opposite reciprocals. Slopes are opposite reciprocals. Now, really, here is kind of a property for perpendicular lines, is that their product of their slopes, typically, M1 times M2 is -1. M1 times, but if you solve for M1, you divide by M2, and you would get the opposite, so negative, and then the reciprocal 1 over M2. So here's where this idea stems from, this property. But this property works for every kind of perpendicular line except for those special lines, the vertical and horizontal, because remember, the slope of a vertical line is undefined. And so, you know, 0 really has no reciprocal, so I wouldn't say this property works for them, but any others it will work for. So what we want to, oh yeah,
Would that
question.
be like a question on this test, so we're going to have to know the difference, like, right, that there was, like, trying to get something.
Right, so what you do want to know, I mean, is mainly this piece of information, because this will work for all of them. Is that good? And vertical lines and horizontal lines, those are just very special lines, and they are definitely perpendicular though. So yeah, I don't know if you need a very special note for that, but I just keep this one handy. Yeah, so what we want to do is to write an equation of a line that's parallel to the given line and pass it through the point -5, 4. Okay. And then we're going to find an equation of a perpendicular line, but let's worry about the parallel line first. This given line is in what one of those forms of a line? If y was by itself, yes. What is another one of those forms?
Standard?
Standard, okay, it is in standard form. Now, I'm going to give you a little shortcut. So you could rewrite this in slope-intercept form. That's an idea. Y equals and get y by itself. But here's a way, if all you need is the slope, This is just a very handy method for finding it. And it's to divide the coefficient of x by the coefficient of y and change the sign. Okay, so I'll write that down. But the coefficient of x is -2. The coefficient of y is 3. Divide -2 over 3. Change the sign of the answer. So positive 2/3. 2/3 is the slope. Is that nice?
Mm-hmm.
Yeah, how nice is that? And I didn't have to move anything. But let me write it down. Okay, so if your form is in this, ax plus by equals c, the slope of the line is going to be negative a over b. Okay, so that means the slope of this line, m, is, so it was -2 over 3, but change the sign, so 2/3.
So coefficient of x divided by the coefficient of y
Uh-huh,
and change the sign.
that is right.
So if 2 is they're all positive, then
Mhm.
make it negative.
That's right, negative slopes, that's it. Okay, so that really helped us with a good part of this problem. We know the slope. We know a point the line passes through, which is -5, 4. And now we just have to write this parallel line. And because parallel lines have the same slope, the new line will have a slope of 2/3 as well. Okay? Okay, so here it is. For number 1, we'll use point slope form. Y minus y1 equals m times x minus x1, where m is 2/3 and the point that we're given is -5, 4. Okay, we're going to use those 3 pieces of information. So y minus 4 equals 2/3 times x minus -5. Okay, that'll become a plus 5.
And you got that using the given point already.
That's correct, yes. Okay, simplify this. Because of time, I'm not going to, okay, but simplify this to get your answer in slope-intercept form. Okay, let me make a note to myself, so I'll post this for you later. Okay, number 2. Now we want to write the equation of a line perpendicular to the given line. But again, we already found the slope of the given line. However, perpendicular lines do not have the same slope. Their slopes are opposite reciprocals. So if I wrote down the slope of my new line, it's not 2/3. What should it be, do you think?
3/2.
3 over 2 and the opposite sign, negative. That's right, -3 over 2. There it is. And now I can continue writing the equation of that line. So -3 over 2.
This is, I'm sorry, what are we doing again?
What we're going to do is try to find the equation of a line perpendicular to the given line, same initial line,
Okay.
that passes through this point, 0, -1. Look at that point. Is that not a special point on the line? On a graph, really. It is vertical, right? The y-intercept, is it not? 0, -1. And how do I know that? Because it is in this form where x is 0. So can we not use slope-intercept form? Right? That is the form I'm going to go to. Can I use point slope form? Sure. Do I need to? No. The fastest way is to use slope-intercept form. Okay, so we're going to write it as y equals mx plus b. Our m is negative 3/2. Our B is given as negative 1. And we're done.